morning, student. In this video, I shall discuss the dihybrid cross phenomenon which occurs in case of Drosophila melanogaster, and it was conducted by T.H. Morgan. And in this dihybrid cross experiment, he explained how actually recombination occurs between the different genes which are present in the same chromosome. Look at the here. He actually took the most suitable specimen, that is Drosophila melanogaster, and this Drosophila melanogaster having some specific character which are very much distinct from one another. Now their body color, sometimes it is brown in color and it is the dominant type, and this dominant brown color having the genotype Y+Y+, and the yellow color, that is the recessive type, and this recessive yellow color, it is taken as small y. Now the eye color of the Drosophila are of two distinct types. One is the red type eye color, it is taken as the genotype Y+Y+, and the white type eye color, it is taken as small w, and it is the recessive type. Now next important character which was observed from outside clearly, that is the wing size. Sometimes the wing size is medium one, that is M+, and the miniature wing size, that is called small m. Now his first cross, or that is called cross 1 or cross A, and in this cross he actually took the parental type as yellow-white, and which is a recessive type, and the brown-red or male. So here now yellow-white type, these are the female one, and these females having the X chromosomes, and in case of males they are brown and red color. These are also called wild type, and their X and Y chromosomes are there in X chromosome, Y plus and W plus genes are there, and they are the wild type. So that is why brown red, this wild type male, and the normal yellow white female were crossed together. And in the F1 generation, what he observed here, in the F1 generation, normally he observed that the dominant varieties or dominant characters were observed here. Now in the genotype, first case here YW and another also YW, and it is called yellow-white type, because yellow-white type, and this yellow-white type, these are the female, and these females were taken, and when this female crossed with the Y plus W plus, and in case of Y chromosome there is no gene in the Y chromosome, so that is why it is here brown, and it is the brown and red, brown body color and red eye color. Now when they cross together, here one genotype you will observe here, that is only YW type of genotype, and here two types of gametes will be formed. Here the gametes normally one type, that is the YW type, and it is recessive one, it is a yellow-white type. Then here two types of gametes, that is your Y plus W plus, and your here Y chromosome there is no genes at all. Now in the F1 generation, what will happen? Now when they cross together, then automatically they will find, suppose this is the female gamete and this is the male gamete, and when this male gamete and the female gamete they fuse together, then they will form here YW from the female and Y plus W plus from male. So in this case, what happened? This is one female which is having here brown and red type. It is here brown body color and red eye color. Now in case of male, suppose this is the female X chromosome from female, and it combined with this male gamete, then it will form here Y, W and another here 00 type. So is 00, it is nothing but your Y chromosome. So in F1 generation, normally here brown, red and here what happened? Here yellow and white type of male are observed. So in the F1 generation, this type of offsprings are found. But what happens in the F2 generation? Whether only the parental combinations were observed or some new combinations were observed. Morgan observed some new combination in addition to the parental combination. Look at here. The gametes which are found here from the F1 generation. This is the F1 generation. There are different types of gametes. This is one gamete. This is another gamete. This is one gamete. This is another gamete. Because they are separated during gamete formation. Now, during gamete formation, these are separated from one another. Now, suppose this will fuse with this one, then what will happen? And when there are different types of organisms, either male organisms or female organisms. First, we observe what are the different types of males are observed by Morgan. So here in the F2 generation, what happens? Look at here. This is the first male. This male is having wild type, that is your brown and red type. Here brown and red type they observe. Suppose here this is one gamete, this is Y, W. This is another gamete, that is your Y plus W plus. And this gamete, in case of male, you will find here what it is the YW, and this is your, there is no gene, that is why it is 00 type. So what happens when they fuse together? Now, when we consider about the male, then this is the female gamete, this is another female gamete, two female gametes are found, and these two female gametes, suppose it actually fused with this male gamete, when it fused with this male gamete, now then what are the different male gametes which are found here? Now they observe some parental types of male organisms they observed in the F1 generation. Now what are these parental generation? Okay, in the parental combination normally observed here, that is your Y plus W plus and another 00, that means it is the Y chromosome. So that is why this type of offsprings are found in the F2 generation. This is the F2 offspring, and in the F2 offspring normally some males are found as the brown red type. So brown red, it is a parental combination because it is the brown red type male, and some males are observed here yellow and white, that is your Y W 00, and it is called your yellow white type. So this yellow white and brown red, here this yellow white and brown red, these are the parental combination. So he observed the parental combination is normally 98.7% of total F2 offsprings are normally this parental type. This is brown red and your yellow white. But in addition to this, he also observed some new combination in the F2 generation, and two types of males are found. He found that some are brown body color and having, this is the brown body color and having white eye color. In the F2 generation, having white eye color. So the brown and white, this type of males are also found. So brown matlab it is Y plus, and here white means that it is small w, and there in the Y chromosome there is no gene. So that is why this type of combination was observed in the F2 generation, which is a recombinant type. It is not the pure type of the parent. Now another variety also he found, that is your YW plus and 00 type. So Y means it is your yellow body color, and W plus means your red eye color, and it is the Y chromosome. It is the male one. So this 00 represents your Y chromosome, which does not contain any gene. Now these are the new combinations which were observed in the F2 generation. Now if this Y plus W plus remain together, now how this new type of combination it was observed here, that is your Y plus W. That means Y plus W plus here it is present, and W plus here it is present, but these are now separated from one another, and Y plus it goes here and W from here. So how this Y plus W and YW plus, they actually segregated or separated from one another, and the new combination Y plus and W and Y and W plus, Y plus W and YW plus, these type of combinations were observed in the F2 generation. And how these were observed? And these were observed only due to this recombination, and due to this recombination during gamete formation, and due to this recombination some new varieties were formed in the next generation or F2 generation. So this new combination, they have the ratio of course very less, it is around 1.3% only. So 1.3% of total F2 offspring were normally new recombinant type, and this recombinant was only possible due to this crossing over between the two genes. Now the chance of crossing over is less here, that is why the recombinant varieties are less, that is why their distance of these two genes are not much more, or it is less. So that is why this type of combination were observed in case of male. Now in case of female also he observed this type of combinations, and in case of female the gametes were the same, but the recombinants which were observed here, look at how the different recombinations were observed. In case of female, the parental combination, that is your Y plus W plus, and the another one it is your YW. So this type of, it is called your brown red type, and this brown red types of female which were the parental type, this is your brown character and red character, both are observed here in case of this female. Now another female which were now purely yellow and white character is a recessive one. Now YW, and another again YW. So that is why this type of combination, this is called the parental combination, and in this parental combination there are around 98.7% of these parental combinations were observed in the F2 generation in case of female. Now the new combination also observed here, that is your Y plus W and YW. So here what happened? Now brown body color and having white eye color. So this brown white, these are recombinant ones, and another that is your yellow and red eye, yellow body color and red eye. This type of combination also observed in the F2 generation in case of female. So here the parental type, of course it is much more, 98.7%, but this brown white, either it is Y plus and W and YW, then here YW plus and YW. So this type of combinations are formed here only due to this recombination of these genes. Suppose YW remain together in the same chromosome, but here what happened? They combined Y plus and W plus and Y. This type of recombination occurred during the crossing over during gamete formation, and due to which this YW plus type also observed here, and here WY plus or Y plus W is also observed in the F2 generation. Of course, this recombination frequency it is less and it is 1.3% only. So this type of recombinants are only possible when crossing over occurred between the genes which are present in the same chromosome. So here the Mendel's 9:3:3:1 ratio, it was not observed. It was not observed in case of Mendel, and this was not observed due to this recombination phenomenon, and Mendel's observation was due to the linkage phenomenon, because the chromosomes the genes which are there in the same chromosome, they normally remain together, but his genes were remain in the different chromosomes. That is why independent assortment was there, and 9:3:3:1 ratio was observed by Mendel. But here this ratio was not observed by Morgan, and some new recombinants were observed in the F2 generation due to this crossing over and formation of the new recombinant by the process of recombination. Morgan conducted another experiment on this Drosophila Drosophila melanogaster by taking another character, and in this dihybrid cross experiment, Morgan took the female organism or female Drosophila having the white normally the eye color, and the wing size is the miniature wing size, which is the recessive type. So both recessive type were there in case of female organism. But in case of males, he took the males having your red eye color, and side by side while taking your normal wing. So when he crossed these two types of Drosophila, the red eye with normal wing, male Drosophila, when it crossed with the white eye and miniature Drosophila, having the genotype here WM type, and in case of males, that is your W plus and M plus, it is also called wild variety, and the male one, and this male do not contain any gene, it is Y chromosome. Now in the F1 generation, what he observed? He observed that the females are having your red eye and normal wing. Here your red eye and normal wing type of females, and the males who observe here, that is your white eye and the miniature wing. White eye and miniature wing. So this type of F1 offspring is observed here, and this is the F1 offspring. Now the red eye normal females, the normal wing female, and the white eye and miniature wing male. Now in the F2 generation, when they form the different gametes like this, here suppose this one and this one gamete, this one another, this one another, like that. But when they combine, suppose WM combines with Y, then it will be this type. Now when this WM with WM, okay, So that is why first we shall consider about the male one, then we shall consider about the female one. Now in case of male, there are two types of combinations we observe. First one, the parental combination, that is your white miniature and red normal. Here, what happened? It is your red normal. This is the red and normal type, and this is your white and miniature type. This is the white and miniature wing. So this type of combination he observed here. These are called the parental combination. These are the parental combination in case of male, and he observed around 62.8% of the parental combination. It is less in comparison to the earlier one. Now here, another new combination he observed in the F2 generation. Normally, in case of male, some males are having a red eye color and miniature wing, which was not the normal variety. Here, this gene, this is your red eye and normal wing. These two genes are remain in the same chromosome, but here they are separated and reunited. So that is why this is a crossing over. So here, what happened? How they separated from one another, and if they will not separate from one another, then how this recombination will occur? So that is why this type of recombination occurs here, because W with M plus and W plus with M. So that is why here it is observed that W plus and M now remain together. How they remain together? Because the crossing occurs between them. Now here normal W and M plus. So this type of recombination also occurs when there is the recombination or crossing over occur between these two. Now in case of female, also same combination occurs, and here in case of some female, they are normal. Your parental varieties are there. Normal parental variety, it is your red and normal. This is your red eye color and normal wing, and here your white eye color and your miniature wing. So these are observed here, and this combination are the parental combination which was there, and this parental combination is observed here. It is around 62.8%, and here also two new combinations were observed here. Now this red eye is also combined with your miniature wing, and your white eye combined with your normal wing. So how this was happened? So this was happened again due to this crossing over which occurred here. So that is why the W combines with M plus and W plus combined with M. So this was possible due to the recombination of these genes. So these genes were there in the same chromosome, but as there is crossing over occurred between them, so that is why they segregated or separated from one another, and they normally go to two different locals. Now here observe that 37.2% of new combinations were observed here. Now that means what? The percentage of recombination is more. That means their linkage or the distance between them will be more. So that is why here either in the red there are W plus, this is one character, and M plus another character. So that is why as there is recombination frequency is more, so automatically the distance between these two genes is more in comparison to the body color and the eye color. So body color gene, that is your YY plus, and your eye color gene, they are remain close to one another. That is why their recombination frequency is only 1.37. But when the recombination frequency is 37.2, it is much higher because their distance is more. So that is why the distance between the two genes determine the recombinant frequency, and it was normally observed by T.H. Morgan. So, from this, it concludes that always there is recombination occurs in the genes now. Thank you very much for listening this, and I hope this video is beneficial for you. If it is beneficial for you, then you please like it and subscribe for the further videos. Thank you.